Okay, this is GCSE Further Mechanics. We're in 1.2 here, velocity time graphs. The previous video we watched talks you through displacement time graphs. That tells you how the displacement changes over time. This is a velocity time graph. It tells you how the velocity changes over time. Velocity is speed with direction. We chatted about that in the last video. We use positive speed in one direction and negative for speed in the opposite direction. In a velocity time graph, the gradient of each section tells you the acceleration. That's fairly vital. You get asked that all the time. This is because the acceleration is the change in velocity over the time taken. So say you change going from 10 to 15 in 5 seconds, that would be an acceleration of 1. It's gone up 5 in the 5 seconds. We work this out using rise over run. A horizontal line indicates an acceleration of 0. In other words, there is no acceleration and the body is moving with constant velocity. The area under the velocity time graph tells you the displacement travels during the motion. It sort of tells you the distance travelled. If there are two graphs drawn on the same set of axes, the point of intersection is the time when both objects are travelling with the same velocity, not when they meet. Find the acceleration of the object at each section and find the total distance travelled. So we need to find the gradient in, let's see, so I'll move this up so everyone can see, in this section, and this section. So first of all, the first section, acceleration equals gradient. Acceleration, then in this case, so where's it going from? It's going up 30, and that's in 3 seconds. So it's going to be 30 over 3. So my acceleration for this section is 10 meters per second squared. Section 2 is nice and straightforward. This is a line here, so I mean it's a gradient of 0. So our acceleration is going to be 0. And of course, you know, as time's going by, if you think about it logically, 3 seconds, 4 seconds, 5 seconds, 6 seconds, 7 seconds, it's going at 30. So there's no acceleration. It's going at the same speed, the same velocity. For the third bit, acceleration equals gradient. Acceleration equals, so what's happening here? Time there, it's going from 7 through to 10, so that's 3. And it's gone down from 30 down to 15, so that's 15. So it's going to be 15 over 3, but importantly it's going down, so whatever one of those you want to pick to be negative, most likely this one would be then minus 15 over 3. So our acceleration then is minus 5 meters per second squared, or if you wish, a deceleration of 5 meters per second squared. Part B asks for the total distance travelled. I'm going to split this into 3 sections here. I'm going to get rid of this so it doesn't confuse. But we're going to try and find the area under the graph, and that'll show us then the total distance travelled. To be honest, it might be better keeping that wee section in, but that's okay. Let's go for it. So distance of this one, so it's 1, that's a triangle of course. So my distance in this case is going to be a half the base times the height. So it's a half multiplied by 3 multiplied by 30. And so that then gives us obviously 45 meters. The second section, length times breadth, obviously that's just a rectangle. And so that's going to be 4, that goes from 3 to 7. 4 times 30. And that's going to be 120 meters. And we'll move down here, hopefully you can still see okay. Yeah, I think we're okay there. You do this a load of different ways. You take the wee triangle and take the rectangle. I'm going to take it as a trapezium because that's what this whole shape is. Feel free, of course, sorry, we should put a number 2 in here and we'll put 3 in here. You of course do a 3 and a 4, 3 for the wee triangle, 4, but I'll do it all in one. So the distance is a half A plus B upon H, a half, and then the 2 parallel sides there, that's a 30. and that's a 15, so it's a half. 30 plus 15, and my h here goes from 7 to 10, so it's going to be 3. Do this whatever way you want. So 30 plus 15 is 45. Half times 3, 1.5. So 1.5, 45. So 45 plus 22.5, 67.5 meters. So then our total distance is 45 plus 120 plus 67.5, and that gives me 232.5 meters.